So continuing with functions, we're going to talk about different types of functions. The first kind is polynomials. So polynomials are kind of the basic function. And we've talked a little bit about linear functions and quadratic functions. Those are both polynomials, but now this is more general. So before we define a polynomial, we first need to know what is a power function. So a power function is always of the form just x to any power. So m is a real number here. So for example, I could have, x squared, that's a power function. Or I could have some function g, maybe x to the 1/2. Those are all power functions. Anytime I have x to a number where that number is real, that's a power function. I could also have maybe h of x is x to the -3. Also a power function. So what is a polynomial? A polynomial is where I take special power functions, add them together, or I could multiply and then add them together. So a polynomial, these are sums of multiples of power functions. But I don't want to say any type of power function. I want to put specifications on what this exponent can be. So I want to say where m is a positive integer or 0. So I don't want to have any sort of fraction as my exponents. I don't want to have anything negative as my exponents. So those are going to be what a polynomial is. So for example, this could be something like 2x cubed minus 5x plus 1. That's a polynomial. I have multiples of power functions. So here's a power function, the multiple there's 2. Here's a power function, multiple there's -5. This doesn't look like a power function because there's no x, but if you think about it, there actually is because I have an x to the 0 there. So constants do count as power functions. So those are fine. So this is a power function. Could also have something like, let's say g of x is 5x squared minus 2x plus 3. That's also a power function. So this is multiples. So my 5, my -2, and my 3, those are the multiples. And then I'm adding them all together or subtracting, which is really the same thing. And every power is a positive integer or it's 0. So the integer here is 1. We don't write it, but that is a positive integer. Now something like, let's say 5x to the 3rd minus 1 over x squared. Now is this a polynomial? Well, the first term, the 5x cubed, that's fine. That's a multiple of a power function. But the second one, even though my power is positive, so I have a positive integer here, if I were to write this as just x to a power, remember when you move the exponent to the top, you make it negative. So this is really x to the -2. Now we see this is not a positive integer, so this is not a polynomial. So anytime we're talking about polynomials, we need to have coefficients, so any number in front of the power functions, and we're adding them together. All the exponents have to be positive or 0. So the general form of a polynomial is f of x is a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus ... all the way down to some a naught. So a naught is going to be your constant term. So this is what a polynomial is always going to look like. It's going to be a number times x to a power plus another number times x to a power, continuing on down until you have some sort of constant. Now the constant might be 0, meaning you don't really have a constant term, and that's fine. Whenever we write these, we typically want to write that n is the largest power, so let's write our largest power first. If we do that, we have special names for anything. So these a(n)s, these are called coefficients. So the numbers that go in front of the power functions, those are your coefficient. This one out front has a special name. This is called your leading coefficient. Now again, we're assuming that n is the largest power here. So that's our leading coefficient. This n, that's the degree of your polynomial. So whatever is the largest degree, that's going to be your degree. And then also, we can talk a little bit about what's the domain of this, or any polynomial, what's the domain? Well, for any polynomial, you're not going to be dividing. You're also not taking any sort of roots, so the domain is always all real numbers. So the domain of f for any polynomial is all real numbers. You can plug in any number to a polynomial. So let's do an example here. If I look at the polynomial, let's say 5x to the fourth plus 2x cubed minus x plus 3. What is the leading coefficient of this polynomial? Well, let's see, the highest powered term is here. This is my highest powered term. So the leading coefficient there is 5. It's the number that goes in front of my highest powered term. And then more importantly, what's the degree of this polynomial? The degree here is 4. 4 is the highest power, so the degree is 4. I'm more interested in knowing the degree rather than the leading coefficient. The degree of a polynomial tells you a lot. So the degree is always the highest power of any polynomial.